To create a 3D GPR model, depth slice, or peak map, you must follow a 3D survey routine. This is the only way to transform 2D data into usable 3D data. 3D surveys take time. In fact, they'll need many more survey lines than a 2D survey. A rule of thumb is to plan for at least double the number of scans over a traditional 2D survey. If you are planning on completing a 3D survey, you must prepare accordingly. You will not get usable results by guesstimating your grid pattern. You must measure and make physical marks. While it is not necessary to use a GPS receiver when carrying out a 3D survey, it does enable a completed peak map or slice to be exported to third-party software, such as Google Maps. It is possible to create points and lines in 3D manually, as well as using the Field to Finish feature. However, for the creation of vector CAD data, it is far more precise to work in 2D and focus on tracing individual lines one at a time. Finally, some notes on data quality. 3D imaging is not a magic bullet. High-quality 2D data is a prerequisite for usable 3D data. In general, if you can't spot a certain target clearly in 2D mode, you won't be able to in 3D either. Fainter and more difficult targets tend to be much easier to spot in 2D. Setting up a 3D grid. The first thing you will need to do is set up your zero line. This will be the line from which the rest of your grid is based off of. From there, you will need to determine your start corner. This will be where the first line of the survey will be located and in which direction your survey will be traveling. There are 4 options for this. It is important that you follow this pattern when surveying, as any divergence from the pattern will cause the data to not match the reality of the site. The numbered lines will be the first axis completed. The second axis, if needed, will use lettered lines. Next, we will have to select the line separation. This will differ for each job, as the size of the target being scanned will not be the same. If you are not sure of the best distance for separation, use the width of the radar antenna, which can be entered into the software as 1.2 feet or 0.37 meters. The quality of the results from a 3D survey are dependent on the number of lines acquired, the separation of these lines, the closer the better, the accuracy of the grid layout, and of course soil conditions. Using a tape measure, you can mark the distance between each line to mark the separation. This can be done using chalk for hard surfaces and marker flags or spray paint for soft natural surfaces. If you will be surveying both axes, which is recommended, make sure to mark out the zero line for that as well. Once your grid is marked out, you are ready to begin the survey. One final note: use the Zig Zag collection pattern sparingly. Most failed 3D surveys result from the use of this pattern with a grid that is not physically laid out precisely enough. It is possible to nudge and reverse lines in Radar Studio. However, one needs to have some idea of how much their collected data was off by in order to correct it. Setting up a 3D survey. To initiate a 3D scan, click on the Area or 3D button on the new survey menu. This will create new options that must be selected before you begin a 3D survey. Enter in the pattern used to set up the grid. Then enter the line separation. Line separation can be entered using the plus or minus buttons at fixed increments, or you can type a more precise value into the field. You will have to choose between a fixed or flex grid. A fixed grid will only run for the user-entered preset distance. The software will automatically stop the scan once that distance is reached and ask to start the next line. This creates data lines with consistent lengths, leading to a cube-like shape. A flex grid gives you the freedom to run each individual survey line as far as needed. This enables you to have L-shapes and other jagged edges on the ends of the survey lines. However, a precise start line is still required for each axis. In order to collect an S-shaped or freeform survey, simply choose a flexible grid. Only collect one line and move the radar in the pattern you wish to collect. It is also possible to have more than one line in an S-shaped survey. Note that these require very precise positioning such as RTK GPS, and most failed S surveys are the result of not collecting in a tight enough pattern. In Radar Studio, when these are opened in 3D, one can choose to use GPS coordinates to display the data in the pattern it was collected in. In later software versions, there is a specific option to collect in this pattern. However, the basic procedure is the same. Surveying in 3D. Once you have all of your settings ready, press OK. You will see this window appear. Press OK again, align the cart with the start corner and the numbered direction you chose, then press the play button to begin the survey, and push forwards. After each scan, you must press stop. After each line is complete, you will need to bring the GPR back to the 0 line and scan the next line in the order of the selected grid pattern. Next, select the option to save this line and continue. The next line will be on the same axis. Then move forward to the end of the survey area. Repeat this until you have collected the lines needed for this axis. If another axis is needed, select the option save this line and continue. The next line will be on the perpendicular axis. From here, you will return to the starting point of the first line and follow the lettered grid lines as selected from the new survey screen. If by chance you make a mistake, you can press the discard and re-record this line button. Please note that this can only be done once per line. When finished, click on Finish this survey. This will allow you to open the survey either as a 3D model or as slices. If you are choosing to only do one axis of 3D data, you can press the Finish Survey button and begin processing and interpreting the data. Note, if you are using only one axis, try to align your survey to be perpendicular to any expected targets. If you are using a fixed grid, run the survey to the preset distance. Once you have reached the set distance, you will see a window that says, "You have completed line number 1 of a multi-line survey. What would you like to do next?" Click Save and Continue to continue surveying. Please note that unlike a flex grid, fixed will not ask when you will be switching to a perpendicular axis. Be sure to start at the origin of the survey and move in the selected direction. Another option is to use the zigzag pattern. In this option, you would run your first line from the 0 line, but you would not bring the radar back to the 0 line for the next pass. Instead, the opposite end will also be a 0 line. You would have to mark the scan lines on both ends, making sure that they match each other. When the model is created, the software will reverse every other line to create the model and slice. It is important to make sure that the user is aware of which line is being scanned when using Zigzag. There is a high probability for confusion and scanning the wrong line. Due to the nature of having 2 0 lines and potentially 4 0 lines in 2 axes, the potential for operator error is very high when using the Zigzag feature, and it is recommended to try to avoid this if possible. It is advised to have the radar in position before hitting any continue buttons to guarantee accurate data collection. The same general guidelines apply to a 3D survey as to a 2D survey, as referenced in US Radar's survey technique training video. Much like a 2D survey, you are able to use the backtrack feature in a 3D survey, although it's not recommended. You are also able to place points in the data. This can be extremely useful if you are going to create models of utilities to export to any CAD software. Any points that have the same description entered will automatically connect to show the path of the target when opened as a 3D model. This is known as field to finish. Make sure that you have unique point names for each unique feature, or features that should not be connected to each other will be when you generate line work.